All right, today we are doing Math 6, Mission 8, Lesson 13. The median of the data set. That is a new word for us. So we're going to get into this lesson a little bit and then get a definition of median. All right, warm up. Here are 2 dot plots and 2 stories. Match each story with a dot plot that could represent it. Be prepared to explain your reasoning. Okay. 20 people, high school students, parents, guardians, and teachers attend a rehearsal for a high school musical. The mean age was 38.5 years. So the mean was 38.5. And the MAD was 16.5 years. All right, that's scenario 1. Scenario 2, high school soccer team practice is usually watched by family members of the players. One evening, 20 people watched the team practice. The mean age, so here's the mean, was 38.5 years. So same mean. And the MAD, or mean absolute deviation, was 12.7 years. All right. So let's think through this. The median is not going to help us, right? It's 38.5. So somewhere around here, right? It's not really going to help us because they're the same. So we have to look at the spread. Which one is more spread out, all right? And what makes the most sense? So this one goes from about 16 to 56. And then this one down here goes about 16 to 64. So just looking at this, I could say that data set B is a little more spread out. But that's not the only thing we have to go on. So let's look at this. Let's think through this. If we were watching high school students, so there's definitely going to be a cluster of high school students, and we see that, right? Age 15 to 20, and here's 15 to 20, right? 15 to 18, around there, right? So that's our cluster of high school students. We have high school students here, and we have high school soccer students there. Then in data set A, we have a nice cluster from 40 to 50, right? So there's a big group of people who are 40 to 50 years old. And then we have one up here, right? But in data set B, we do have the 40 to 50 range, but we also have the 30 to 40 range. So that's a little spread out. And then we have a cluster up top between 60 to 65. So if I'm thinking through this, parents, guardians, and teachers, I probably think that's going to be a little bit more spread out in ages than just family members. Because family members, it's usually the kids and then the parents. And so if it's the kids and the parents, they're probably going to be a cluster of kids and then a cluster of ages of parents that are about the same age. So if that's the case, and the parents and teachers at the high school musical, that's probably going to be more spread out. So I would say this is the musical and this is the soccer practice. Now, if we looked at MAD alone, the musical is 16.5 and the soccer is 12.7. And we did say that data set B was a little bit more spread out than data set A. So that would make sense. Another evening, 20 people, oh, I forgot. We're going to skip this one. This one, it's not going to help us in the long run. It's just because the MAD is 20 years instead of 12.7 or 16.5, it's going to be more spread out. But I don't want to have to graph that with you and talk you through that because it gets confusing and it's not worth it to get confusing. So we're going to skip that. Activity 1, task 1. Here's a table that shows the numbers of siblings of 10 students in Tyler's class. So we should have 10 data points. There they all are. Represent the data shown in the table with a dot plot. All right, so our lowest number is 0 and our highest number is 10. So if I'm going to draw this, it's going to look like that, and we're going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. For each data point, we're going to do a dot. So we have 1, 0, 2, 1, 7. Big family. 0, 2, 0, 1, 10. Wow, big family. All right. Based on your dot plot, estimate the center of the data, without making any calculations. What is your estimate of a typical, there's that word again, typical number of siblings of these 6th grade students? Mark the location of that on your dot plot. Okay, well, we have a data cluster down here. So I would say my center is probably going to be around there. And I'm going to guess it's probably around here. I'm sure it's going to be a little bit more above 1, just because we have this data point and this data point that's kind of pulling the center up a little bit. But I'm going to say that without doing any calculations, my center is about 1. All right, find the mean. So we have to add all of these up. So we have 0 plus 0 plus 0. That's our 3 dots on 0. Then we have plus 1 plus 1 plus 1. That's our 3 dots on 1. Plus 2 plus 2. That's our 2 dots on 2. Plus 1, 7, and 1, 10. So here we go. You know I like to cluster. Oh, the one up top said mark it, mark the location of the number. So I would mark on 1. All right, let's jump back into this. You know I like to cluster. So that's 3, 4, 5. That's a 5. And then that's a 9. And that's 10. So 10, 19, 20, 21, 22, 23, 24. So this equals 24. And how many data points do we have? We have 10. So we have to do 24 divided by 10 to find the mean, which is 2.4. Because when you divide anything by 10, you take the decimal point, and there's an invisible decimal point after 24, and you move it over 1, 2.4. All right. How does the mean compare to the value that you marked on the dot plot as the typical number of siblings? Is the mean that you calculated a little larger, a lot larger, exactly the same, a little smaller, or a lot smaller than your estimate? Well, it's a pretty bad estimate. So no, it's bad estimate. It does not compare to 2.4. 2.4 is larger. I would probably even say a lot larger. The mean is a lot larger than my estimate. Okay. Do you think the mean summarizes the data set well? Explain your reasoning. I don't think that it summarizes it well. So I'm going to say no, it doesn't. 8 out of the 10 dots are down here between 0, 1, and 2, right? So because of that, 8 of the dots are below the mean. Does that make sense to have 8 of the dots below the mean and have the mean be a good summary of the data? No. So 8 of the dots are below the mean. 8 of the 10 dots are below the mean. So when you have the majority of your data below the mean, it isn't a good summary of the data. Not a good summary. more than half of the students have either no siblings or one sibling. So to say that 2.4 siblings is a typical number isn't very accurate. All right, so we're gonna figure out something that could be better to summarize the data. The mean is always gonna stay the same. The mean is 2.4, but that's because we have this 10 that's up here and this 7 that's up here, and that's kind of pulling the mean up higher than it normally would be. So instead, we need to look at the median. See this word right here? The median. So the median is the middle of the data. The mean is the average, so that is right in the middle of all of the data, but the middle, the median, is going to tell us the middle of the data points. So it's a little different. Here's the data set on the number of siblings from an earlier activity, the one we just did. Sort the data from least to greatest, then find the median. All right, so we have 0, 0, 0. Then we have 1, 1, 1. Then we have 2, 2. Then we have 7. Then we have 10. So this is how I like to find the median. You start at one end and you cross off the first one, and then you start at the other end and cross it off until you meet in the middle. Okay? Because that means we're taking 1 from each side. So like this. 1, 1. 2, 2. 3, 3. 4, 4. And then we have 2 left. But the good news in our activity is that these are both the same number. So in this activity, when you have an even number like this, to find the median, you would find the average of the two numbers together. So 1 plus 1 equals 2, and there's 2 data points, so you divide by 2, and that equals 1. So our median for this data set is 1. Okay? So basically, we are literally finding the middle of the data. Okay? So in this situation, do you think the median is a good measure of a typical number of siblings for this group? Yes, I really do. Because one sibling is in the middle of where most of the points in the data set are. If we go back up here, you can see 1 is the middle of all of the data points, which and it is also the middle of 8 out of the 10 data points. So I would say, yes, it's a good measure of the typical number of siblings in this group because it's the middle of where most of the data points are. Okay. Here is the dot plot showing the travel time in minutes of Elena's bus rides to school. Okay. Find the median travel time. Be prepared to explain your reasoning. So watch, I don't even have to write, like take the numbers and write them down. I could, but I don't have to. Let's start that way though. So it's 6, 6, 7, 8, 8, 8, 9, 9, 9, 10, 10, 12. All right, now I'm gonna do my little trick. I'm gonna cross off 1 at the bottom, 1 at the top until I meet in the middle. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, And then I have these 2 that are in the middle, so I have to find the average. Find the average of the 2. All right, here we go. 9 plus 8 is 17, right? And then I have to divide by 2. So 17 divided by 2. Well, I know 2 goes into 1 0 times, and I know 2 goes into 16 8 times. 8 times 2 is 16 minus 1. Now I have to put my decimal, bring the decimal point up, and add my 0. Then bring my 0 down. 2 goes into 10 5 times. 5 times 2 is 10. 0. Oop. It is 0 down here, and there is no other number out to the side, so I am done. So 17 divided by 2 is 8.5. So our median is 8.5. What does the median tell us in this context? So it tells us that half of our trips to school took 8.5 minutes or less, and the other half took 8.5 minutes or more. So let's write that. Median tells us that half of her trips to school took 8.5 minutes or less, and the other half took 8.5 minutes or more. And we know it's half and half because this is exactly the middle. Median equals the exact middle. Now let's go back up here, and I'm going to show you how to do it without writing out all the numbers. So I could go 6, 12, 6, 10. Notice when I start, I cross out from the bottom what's closest to the number line and then go up. All right? Then 7, 10, 8, 9, 8, 9. And I'm left with 2 dots, one on the 8, one on the 9, and I have to find the average of that, which is 8.5. All right. The median is another measure of center of the distribution. It is the middle value in a data set where values are listed in order. Half of the values in the data set are less than or equal to the median, and half of the values are greater than or equal to the median. To find the median, here we go. Ooh. To find the median, we order the data values from least to greatest and then find the number in the middle. Okay? All righty.